in terms of AP Calc, we see a small amount of homework like that. I'm giving it to you to really let you think about what all can happen to you in homeworks and tests in college and physics and engineering and your job and, your law practice and medicine and whatever it is, you know, raising children, whatever it is that you're gonna do, you're gonna be hit with some surprises, and the best of the best are gonna figure it out, okay? So, you know, I don't hold back at all. In fact, I far from hold back in calculus. I just throw it all at you and you perform wonderfully. There are some things that some of you have already talked to me about, and some of you are still sitting there going, how in the heck am I gonna do number 41 and whichever other number? And a few people met with me about 41, and so they'll see it again. I like Slater and CalcChat and that you can check your answer. Slater and CalcChat, I don't know if you remember me saying this at the first of the year, but also sometimes before online checking of your work, people used to come upstairs, or at my school, we had somehow purchased with a grant, my public school, not my public school, the public school I was at. We had some sort of grant where we had tons of solution books and actually calculators for the kids to check out. And so people would come through the solution manuals and they would have a solution manual for everything, but obviously we don't want to spend money on that now because you can check it on Slater and CalcChat. Slater's a bit like Wikipedia or Reddit or something in that you kind of got to look at it with a grain of salt. Like, I think anybody can throw in their solution. CalcChat is like what we used to buy a solution manual. So you can depend on CalcChat, but I don't know if you remember me saying this. Back in the day that we had hard copies of solution manuals, the same thing happened. It was so weird. We got into like Cal 2, and it was like some alien had landed and started writing the solution manual, whereas my students were depending on it. And I found out when they would come to me and go, what is this? Like, I would go, well, the answer's right. I don't know how they got there, but that looks really weird. It's not even the way that, like they hired someone, like somebody quit and they hired someone else to fill in the gaps. And you'll find that on Slater and CalcChat right now, and I'm sorry, it just happens for a few months where I don't really agree with how they're presenting things, but at least you can check your answers, and sometimes you can get ideas. If you think about how far you've come, a lot of you are the kind of student, unlike me, that already is so good at critical thinking that you think of these things, and you're looking at everybody else like, why didn't you think of that, okay? I was not that person. I've shared that with you before. I sat there in Cal 1 going, okay, that was really cool, but I would have never thought of that. And it scared the daylights out of me, like how I'm going to try to major in math, and I'm going to, you know, try to do this, that, and the other thing, and hang with these people that are apparently so brilliant. But I don't really know how their story transpired, but I know my story transpired in that I-R-E-A-L-L-Y. I really, really worked on my homework. And as people showed me hints and tricks and they're not really tricks, thought processes, I did start to do those. I may not have been the first thing to think of it. It doesn't matter to me as long as I think of it in time to, you know, get the problem right. And the more you see of what someone else thinks of or what you think of yourself, it starts to blend into your own critical thinking skills. I'm a much, much better critical thinking, as in, I guess I probably had zero. My siblings were making fun of me again last night in the group text. And then look at my husband, I'm like, they're making fun of me again. Because my sister found the meme about Chester drawers. Have y'all ever seen like a chest of drawers? Apparently there's a meme going around about Chester drawers. Anyway, I didn't remember it, but they were both laughing like, remember when you asked Mom and Dad why they named it like after a person, like Chester drawers?
You thought that a chest of drawers
was Chester drawers. Which, you know, some furniture is after a person, like the whole Ethan Allen store. So I mean, I'm thinking that's not so stupid, but I did a lot of stuff like that. Yeah, they can fill up our group chat with memes of my non-critical thinking skills. Anyway, you can do it, okay? So open your mind and follow the lead of people that have gone before us. So let's go ahead and look at 41. And then we'll go to some other ones. 41,
also do 23.
We sure can, just a second, we will.
And 80.
I'm just glad you have meaningful questions, that's awesome.
Oh.
Okay,
I'm
hang on.
so confused.
All right, so, 41. 41 is, oh, what I was gonna say before y'all started peppering me with more questions, which is great, is, if you can do these integrals right now, you're right where you need to be because they require everything I've taught you so far. Whether it's, you can simplify it and just do it, substitution, inverse trig functions, those are the three things that you've gotta think about along with all these different, what I call engineering the problem so it will work for you. All right, so I'll talk you through my thought process on 41. On 41, I literally do what I ask you to do. X squared plus 4x, 6x plus 13. Since I just taught you that trick, I shy away from calling completing the square, but engineering a perfect square so that you've got maybe arctan or arcsine or something. Don't try that first. Look to see, back off of it and go, should I do long division? If that was 2x cubed over x squared, I should be doing long division, okay? My next, I couldn't simplify it. You know, you can want to think about, can you already factor it? It's kind of funny once we start talking about the engineering of making a perfect square. Then students don't even realize sometimes they have something that factors and they didn't need to do that. Pause for a minute. Just because it factors doesn't mean that you don't need to do more to it though, because if you're doing the inverse trig functions, you need a squared and a squared. Not just x minus 3 squared, you need like x minus 3 squared plus some other number. I'll address that as it comes up. Next, I stopped at substitution. You probably did too. I doubt you wrote it down, much like me. But later on, as I was stuck on this problem for just a little while, don't panic, but I thought, how am I gonna work this problem? I decided, based on experience, that it was gonna help me to write this down. du was 2x plus 6, and I'd already done that in my head, and I knew it wasn't gonna work because I only had 2x, I don't have 2x plus 6. So I abandoned that and went to completing the square like you did also most likely. And so I wrote it as 2x over x squared. The way that I do it is I move there's other ways to do it. In fact, I honestly didn't do it this way, but that's how I teach it consistently. I broke it up into 9 and 4, and some of you may have intuitively done that. That's fine. If you didn't, and you're thinking, I want two things that are squared, you can take half of this number and square it, not because someone taught you a process, but because you understand what's happening. Like this has to be x plus 3 times x plus 3 for this to work, doesn't it? Mm-hmm. All right, so if I have to have x plus 3 times x plus 3, that's going to give me x squared plus 6x. I have to have a 9 at the end. That's why that's working, okay? So I'm going to add a 9 and subtract a 9, which many of you probably did or something similar. So that gave you 2x over x squared, x plus 3 squared, x plus 3 squared plus 4 dx. Which seemed great, and I'm like, okay, I have an arctan, but if I have an arctan, now u is x plus 3, and du is dx. And then I was thrilled as I started seeing some of my best thinkers come by and ask questions like, what am I going to do now? Because you realized you were stuck. Hopefully everybody in the room was just too busy, or you figured it out, or if you read Slavery, you may not have known what in the world they were doing, but you knew I would explain it in class or whatever. I don't think I even did it like they did, but I didn't look at theirs. I just did it this way, checked the enter in the back, and it was there. So I was stuck, literally, okay? I'm like, okay, none of this is fitting, but I know it's a non-calculator problem because I don't have limits of integration. All right, so then what I did was I went back to this original substitution and I thought, what can I do? I thought, I surely wish I had a 2x plus 6, don't you? And I say that, and this is the way I think of it, critically thinking. I'm thinking, I surely wish I had a 2x plus 6, and then I realized, what if I can get one? It's like, here, I surely wish there was a 9, so I got myself one, okay? So I surely wish there was a 6 here, but if I put a 6, don't I also have to subtract 1? Then I broke it up into 2 fractions, and then the light started to come on. I have 2x plus 6 over the original denominator, and then negative 6 over this factor denominator. Because I'd already played around with both situations. Do y'all see what I mean? Okay. That one I can do with substitution, and that one I can do with arctan. Okay. All right. So so that's what I did. I just got it for myself. Now, when I say original denominator, they're both the same denominator. One's just in a different form than the other. I don't know why sometimes it does extend page and sometimes it doesn't. It's just like not going to do it here. There, now I've got it. I don't know how it makes this decision. So this one I already had set up for du, and I had 2x dx. So I had the integral of 1 over u du. It was just a perfect fit. Minus 6 times the integral of 1 over x plus 3 squared plus 4. Make a note to yourself always. I slip up when I try to do these too fast. I've reminded myself that u, or if you didn't want to reuse u because you used it for something else in your notes, you could call it use of 1 and use of 2. If you like u's, you can call 1 u and 1 w. I just was working my way to show it to anybody, so I just called it u, okay? So u I called x plus 3. Girls, please stop at that moment and make sure you don't have a du that you need to take care of, but du would be dx, so I'm okay. And also just make a note to yourself of what a is, just so you'll remember to take care of it. All right, so this side is ln u plus or minus 6. Now I'm taking the integral of this. Arctan is one that has a 1 over a in front of it. Arctan of u over a plus c. And so I got ln, my u was x squared plus 6x. What was it?
13.
Plus 13, thank you. Minus.
Shouldn't it be x plus 3 over 2?
Oh, 2.
Yeah. X plus 3.
It's, and I think
That is a 3.
Oh.
It's a really ugly.
Oh, I see.
Okay.
I understand.
Arctan of x plus the really ugly 3 over 2 plus c.
I have a question.
Okay, so, and I think that was the answer. I have notes.
Yeah. I
Okay.
have a question. Okay, so
Okay.
since this one's addition, like I mean, so like it doesn't matter which one is A or U, like I guess, right? But like
It says it's addition, but that u's got to be the
U has to be the
variable.
one from there.
Right.
Okay. just
You,
making
it
sure.
doesn't matter what order they're in.
Yeah, but okay. That
U
was what I
has, you can have 4 plus x squared or x squared plus 4.
Yeah, okay, but the U is always the one.
Use the variable,
Okay, 'cause
A
that's
is the
why.
number.
Yeah, like
Yeah.
like, okay.
Use the variable as number. Great questions. This is exactly what we need. All right, there's a bunch of other things coming at me, so what other numbers do I need to do?
You go over 89.
All right, we're doing 89. All right, sounds like there's a consensus for 89. And I'll keep giving you some pretty interesting things to do. All right, 89. 89, I have the integral of arctan of x over 2 over 4 plus x squared dx. Now as you know more stuff, I'm going to let u be arctan of x over 2. And because I know the derivative of that gives me some sort of x squared thing, so I'm thinking I might have a good fit, okay? Plus you don't yet know how to integrate arctan or logarithms for that matter. I haven't taught you that yet, okay? So du is 1 over 1 plus u squared times the derivative of u. Set up your chain rule so you won't forget. When you have u squared, du is 1/2 dx, my differential. So I have du is equal to, I'm gonna leave this 1/2 out here. This one I'm gonna clean up into 1 plus x squared over 4, but I'm actually gonna make it like this just to speed along. This is x squared over 4, and then I got a common denominator. Y'all okay with that? No?
No.
Okay.
Wait, do that again.
This part is 1 over 1 plus x squared over 4. Okay? And then I got a common denominator on the bottom, which would have made it 4 plus x squared. Wouldn't I change this into 4 over 4?
Oh, yeah.
Because I gotta add those together. If I'm gonna add a fraction, I need a common denominator. Another option here, girls, that I'm a bigger fan of is none of us like fractions, obviously still, because I have a few faces in the room that are like, ugh, okay? Remember with limits, I told you, if you have a fraction, listen up, girls. If you have a complex fraction, you can multiply the top by whatever, and you can just multiply through by the common denominator. And that gives me 4 over, sorry, write it down here, 4 over 4 plus x squared, which is what I'm gonna get here eventually. Alright, so find your way that makes sense to you. So let me back off of this for a minute. And so let's do it more slowly. This is 1 over 1 plus x squared over 4. And you could get a common denominator, and then I think a lot of your teachers in middle school said keep, change, flip kind of thing. But if you have a fraction in your fraction that's called a complex fraction, you can multiply the top by the common denominator and the bottom by the common denominator. And that also takes care of it. So I had dx was 4 over 4 plus x squared. I also still have this 1/2 out here, dx. You've got to be careful, okay? So this, thanks. This is du. Thanks, Grace. All right, so this is going to be a 2 right here. And I probably don't want that 2. So I'm going to make this 1/2 du is equal to 1 over 4 plus x squared dx. You cannot move really fast through these or I'll make a mistake, okay? So you might also. All right, now there was some talk about algebra in there, which there always is. But remember my instinct of letting u be arctan, I thought it would give me something on the bottom with a squared in it. So that's why I was willing to try it. And, you know, at any point you can move that 1/2 or deal with it, but you have to deal with it. All right, so now let's go back up here and, sorry. Let's get rid of this so that we can write next to it. All right, so I have the integral of arctan x over 2 is u, and du way down here was, 1/2 du is the rest of it. So I have 1 over 4 plus x squared dx is 1/2 du. It's what became a very ample integral, okay? Then I have 1/2 u squared over 2 plus c. U is arctan of x over 2. And so maybe they had I don't know what they had, arctan of x over 2 squared over 4 plus c, or 1/4. Did they have that?
Yeah, they have 1/4.
Okay. You're probably a lot like me, in that once I get started on these, much like an identity, I'm ready to hurry up and see if my idea is going to work, and I stumble over the arithmetic and the algebra. So a lot of times I like to kind of forge ahead, but then I've got to go back and be careful with my arithmetic, okay? And I'm trying to let you know what would trigger me to think of these things, okay? Too, because it's out there. To make me think, what's the key to unlock these problems? Okay, other questions? There were some more. Sophia? 85. All right, so this is 85. And any of these could pop up on any homework, any test, anytime. These are not exclusive to this. 85. All right, so the integral of 1 over e to the 2x plus e to the negative 2x dx. All right, now listen carefully. When I'm looking at 1, and by the way, there's a chance that this throws us into something I'll teach you later called logistic, or that hyperbolic sine and cosine that I mentioned one time for 3 seconds when you may not have heard me mention it. I don't really know why it's not part of the mainstream calculus curriculum. I know I've dealt with hyperbolic sine and cosine myself very little, but there's a lot of application of it on suspension bridges or anything that's called a catenary curve. In fact, if you've ever sat in a classroom, it drives me crazy when I go to a workshop, like in another math class or something, and I see a poster with the, if you've seen the arch in St. Louis, and the poster or the teacher has said it's an example of a parabola. It's not parabolic, it's what's called catenary. And it has to do with all this hyperbolic sine and cosine that makes these equations that actually do this. Instead of being out like this, it's more tailored. It's not quite vertical, but it's a whole lot more sturdy. When I have taught it in a few classes before with a catenary curve, I have, you know, a lot of times you can take off a necklace. You need something with a weight on it. And when you hold it, it's not really parabolic. Can you see it would pull it to where it's more, I mean, I can take mine off and do it, and then I have to try to get it back on again, which I hardly ever take it off. But anyway, can y'all see if I'm going up in this arch, I probably don't want it to be parabolic. This gives me more support. So let's move on. But anyway, all of that hyperbolic stuff could crop up. Back to this, I hadn't taught you that can't happen. So what I was gonna say that I wanted everybody to listen to is how do I make my decisions to get these right? Because I love working these, I love identities. I'm like, I think it's really fun if I have time to, obviously I'm not under the constraints of a test or a quiz. But one thing a lot of times I do is about the only thing that I can think of to do if I'm stuck. Sure, if you let you be the bottom or one of the two things, you might feel like you were still stuck, okay? But what else is it begging you to do? Sometimes I do what I'm saying it's begging me to do, like that x squared minus 6x plus 13 was begging me to try to get a perfect square. You tell me what's the only thing you can do?
Like do 1 over.
Let's get rid of that negative exponent, okay? So this is the integral of 1 over e to the 2x plus 1 over e to the 2x dx. Then to me it's begging me, Morgan, watch this because this is what we're just talking about. It's begging me to get like a common denominator, blah, blah, blah. However, based on what we just talked about, some of you may want to get a common denominator right here and add it and keep change flip, multiply by the reciprocal. Or we can do that skill I just talked about. We can multiply the top by e to the 2x as long as we do the bottom by e to the 2x. So now I have e to the 2x. This is e to the 4x plus 1. Does anybody recognize what this is starting to look like? Arctan, very good. Okay, isn't that e to the 2x squared if you know your exponent rules? Girls, the only way I got that was going, this is begging me to do something with that negative exponent, okay? So now, I'm gonna let u be e to the 2x because that's what's being squared. Du is 2, okay, let's slow down here. The derivative of e to the 2x is e to the 2x times ln e times the derivative of 2x, which is 2. You have all of those components every time. It's just we have so much base e, it makes me scared you're going to get lazy if you have another base. All right, so this is 1/2 du equals e to the 2x dx. It's really fun how these fit together. It's very, like you said, satisfying when we were working that long problem the other day. E to the 2x is 1/2 du, or du over. This is 1 over u squared plus 1. Make a note to yourselves that a is 1, just so you're careful. All right, so this is 1/2 arc tan of u, which is e to the 2x, over a plus c. And I think that was the answer.
Yeah.
By the way, I looked back at that really long one where I had to do all that FOIL the other day with that differential equation, show that y double prime minus 10y double prime, or whatever that was. I looked around on a few sites like Slater and CalcChat and solution manuals, and they did the same thing I did. So I I don't know if there's an easier way than just to go ahead and do it, okay? Okay? Other questions? Ready to move on? Okay, so, get out your test. We'll talk about that for a minute. I just keep drawing the line underneath things. Well, apparently I didn't make myself a note. Have we done number 10?
Yes. Yeah.
Oh, I did. Okay, be really careful about that, things like that. Number 11, you slap it into your calculator, but look at 11. All right, number 11 is f is the antiderivative of x squared over 1 plus x to the 5th. You know, f of 1 is 5, and f of 4 is what? Okay, this really satisfies the argument of, well, you can use a calculator so you can make a great grade on the AP exam. We all know that's not true at this point. You know, I could let you use a calculator. I don't think I banned it from the last test. Having your calculator made a big difference. But did I say no calculator on
I don't
No,
know.
you didn't.
But you didn't like need it for most of them, right? You like couldn't. Yeah, you couldn't. Yeah.
this? Sorry. Somebody just texted me in all caps, which always makes me worry.
That's why I like text people who don't respond fast. I just text them all caps so they think it's an emergency.
Well, I kept texting my husband in all caps yesterday, yeah, because when we get in a group text with like family members or friends, he forgets. And fortunately, he hasn't transgressed too much, but they don't want to know how much he loves them. You know, or like, he's like, oh, can you pick up such and such on the way home, if he's already home. And one of my friends in the group text from Mississippi, Amy, who actually was a former student of mine, Amy, said, that's kind of far. She was in Oxford, Mississippi. She's like, that's too far for me to go to get her for it. I said yesterday we in a group text, and I kept caps, like I sent him 16, you're in a group text, 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 because he always forgets. And text everybody.
So he thinks it's just you.
Yeah, he thinks he's just telling me. Thank goodness he hasn't like, I really hate so-and-so, or, you know, anyway.
Oh, my parents do this all the time. Because my family, we have like group chats with like every combination of family members.
Yeah.
Yeah, so like they'll just.
They
they'll
forget
just, like,
which
text me.
combination.
Yeah,
You
like,
can
like
believe
my
how she
brother's at
acted.
college and we'll just like talk about like what we're doing on Sunday morning. My brother's
I
like,
don't
shut
care.
up. I don't even.
I don't care. Okay, so anyway, back to this. If f is the antiderivative of, all right, so if they tell you f is the antiderivative of something, that means it's the integral of that, right? So that means if I integrate this, I should be getting f of something. So this is f prime. You should make all of those notes to yourself. If it says f is the antiderivative of blah, that means you're looking at the derivative of f because they took the antiderivative to get it, which ties into all the graphs you want to see eventually, of some of you that mess that up. Now, limits of integration. I would obviously want to use limits of integration numbers that they gave me, 1 to 4. So by the fundamental theorem of calculus, if I integrate this, it said the antiderivative is f, so that takes me back to f of 4 minus f of 1. Okay, let's pause for a minute, Carla and maybe Sophia, or maybe Alana, I'm not sure who all. Even though I trust you to keep up in my class, and I don't monitor, you know, my Algebra 2A students, I make them close their computers, there's no reason to have a computer open right now. But I'm kind of guessing people around you just want to focus, so maybe if you go point and not talk if you're looking at something. So it's just a little distracting to me, I don't know about your friends. Okay. Thank you. Did I overstep my bounds? Were you doing something with calculus or just placed to talk?
Well, we were on Slater and checking what's for lunch at the same time, so. We were
Checking
both on
lunch?
Slater and checking for lunch.
Oh, lunch, I think you call
What's
it.
for lunch? Grilled mozzarella and panini. Tomato panini.
So anyway.
I think I was second, I was maybe this morning.
Okay,
Oh,
hello. Alright, so it was a fundamental theorem of calculus question that I need to make you react and go straight to, okay? It said take the antiderivative of this, will take you to F. You punch this directly in your calculator when you're on the calculator active problem, especially you see all these decimals. They gave you F of 1 is 5. And so I find this number and add 5 to it, and I got D, okay? All right, now, let me keep an eye on time. Slope field, I don't wanna do that whole problem. You did pretty well on the slope field, and I think a lot of you know where I wrote the mistakes that you made. On C though, let's look at C on the slope field. Now your slope field looks somewhat like this. I'm not trying to do it really good right now, but anyway, everybody's slope field looks sort of like this, which really to me looks very elliptical, okay? Do y'all see how if they put a point here, I would draw this ellipse? But girl, that's not a function, okay? Or I might draw this ellipse, but that's not a function. And so what happens if you have an ellipse, you would have something like different coefficients, like that. And if you solve for x or y, if you solve for y to try to call it a function, you get a plus or minus eventually. Are y'all with me? 4y squared equals 1 minus 3x squared. Divide by 4. This is not this problem, by the way, I'm just talking. 3/4 x squared. And then when I square root, I should say plus or minus. And I've got to pick which one they want me to have. Do they want the top one or do they want the bottom one? By the particular solution they're talking about. So big deal there, hardly anybody caught it. Sometimes they'll even say, draw something through the point 1, -1. And if you're actually drawing through the point 1, -1, you would have drawn this thing that really actually on your paper was probably steeper. I didn't draw it very well. But you see what the bottom half when you get the plus or minus. So let's work the problem. And so, separation of variables, find the particular solution. And so, what did we have? dy over dx equals -2x over y that was it. All right, so I'm going to separate my variables. You're going to racking up points here when you do this. There's going to be one. Y dy equals -2x dx. Make sure all your x's on one side, your y's on the other side. You really want all your coefficients over there also. If this had said -2x over 3y, girls, I would not have taken that 3 with it. Because it runs me into a product of maybe a substitution I don't want. So I'd have left it over there. I've said that many times, leave as much behind as you can. Then I integrate, and that gives me y squared over 2 equals -2x squared over 2 plus c, or y squared over 2 equals -x squared plus c. And I'd say right now fill in the point to find c, okay? Once you've called it a c, it does matter. And so I have 1/2 equals -1 plus c. So c is 3/2. Sorry, I'm moving fast. So that gives me y squared over 2 equals -x squared plus 3/2. Pause for a minute. Can y'all see why I said it's an ellipse? If you add this, I know y'all didn't study conic sections a whole lot. Usually it's in algebra 2 and then you hit it again in pre-calc, but I think we only hit it in pre-calc really fast. But do you see how if I move this over, I have an x squared plus y squared that would be closed, like in a circle or an ellipse. If I solve for y, multiply by 2, and then when you square root, you're doing plus or minus the square root of this. And since they have me at the point 1, -1, they're trying to pull me down to that one. If you graph that on your graphing calculator, you'll get a picture like that. It would go through 1, -1, okay? All right, so let's go ahead and look at the last page. Let's look at the last one, so we're done with the test. And let me tell you that you are going to have a quiz on next class. I'll give you a packet with answers that you would study for the quiz. Originally, if you looked at the syllabus, if they've even posted it lately, it would have said like a quiz on inverse functions, derivatives and integrals of inverse trig functions, but it's not that. It's going to be more on like pictures and putting things together. And so let me do this one. I'll give you a packet. You can study as much or little of it as you want. You can kind of, it's a lot of it's the same. It's 3 worksheets and all the answers are provided, okay? If I have time, I might work some on a video or something, but if I don't do that, certainly come by and we can work them together.
When is it?
On Monday. Is that our next class?
Yeah.
Yeah, so you've got some while, or email me, like a girl last night asked me a question and I'm like, send me a picture of your work. Then I was able to answer her question. Or I could send a picture of my work, or whatever, okay? All right, so on this one, I may have already addressed it a little bit when I gave the test back, but we don't even have this quadrant. So it goes like this, and that's a semicircle. When you see a graph, you're gonna be asked things about area, maxes, mins, points of inflection. You're gonna be asked that, which I had said, but apparently not enough, okay? This is 2. This is 4, no, this is 3, 4, 5, 2, 1. This is -2. All right, and this is a 3. All right, so I'm going to get away from this picture as fast as I can. And I'm going to make myself, by the way, they said g of x is equal to the integral from 1 to x of f of t dt. If somebody walks up to you and said, hey, I took the integral and I got g, then what's behind the integral symbol? The derivative of g. Great, Morgan. If I integrated something and got g, then f must have been g prime. Make a note to yourself right away that that right there is that expression behind every integral symbol is a rate. It's the derivative of something. That's the fundamental theorem of calculus. Okay? All right, so anyway, that's g prime. They told me this was f. The graph of f is given, so I made myself a note. No, it's not, it's g prime. Before I even read the problem, I did a g prime and a g double prime chart. Because I want to do it right now. I don't want to like second guess myself. You quite literally ask yourself what this is to tell you what something's doing. What is g prime, which is f? It is 0 at 3. Before 3, it is negative, and then it's positive. That means I know where g is increasing and decreasing for later answers. Okay? G prime is the derivative of g double prime is the derivative of g prime. So what this is tells me what the one before it was doing. Okay? It's doing something important right there. In fact, you see its derivative would be undefined, which is important in calculus. It's continuous, but yet undefined. Like this, wouldn't you argue that an absolute value graph, that's a real important point. That's where my derivative is undefined, okay? So my derivative is undefined at 2, and where would the derivative of this be 0? 4. Okay? And this is really weird. This is doing nothing. So its derivative is 0. Isn't that a constant? Mm-hmm. And then what is this doing all the way until 4? Increasing. So your slopes are positive. And then what would your slopes be here? Negative. So I already know about concavity also. Okay? By the way, can anybody tell me if at 4.5, if this was an object, would it be speeding up or slowing down at 4.5?
Slowing down.
Why?
Because it's in the negative. The slopes are negative.
Because like it's concaves down and decreasing.
Wait a minute.
Gracie.
Its velocity is positive.
It's positive, but acceleration.
The acceleration's negative.
Oh yeah,
Different signs means it's slowing down. Okay? if I am going in the positive direction, which is that way, and I push my accelerator down, I'm gonna go faster in that direction. I've got a positive accelerant with a positive velocity. But what if I'm going 40 miles an hour and I put my foot on the brake? I have a negative accelerant. I'm still going that direction, but I'm slowing down. If I drop this pin, do you know why it speeds up? It has an initial velocity, but gravity is negative 9.8 meters per second squared. So it has a negative velocity while something's pulling on it. Two negatives are gonna make it go faster, okay? What if this is dropping in a little, that'd be really cool, a little parachute opens, okay? That parachute is a positive accelerant, isn't it? It's slowing it down. It's still going down, but you've gotta look at your signs. So right here, the only place it would be speeding up would be between 3 and 4. I'm off topic right now, but in order to see all of that, many times I'll put some more plus and minus signs so I can actually see where I'm looking. Like right here at 4.5, I saw that I had different signs. Velocity's positive, acceleration's negative. People make this mistake all the time when they're asked on the AP exam or on one of my tests, is the object speeding up or slowing down? They base it solely often on the velocity or the acceleration. But just because it's going down doesn't mean it's going down fast. So look for different signs of slowing down, same sign, velocity and acceleration is speeding up. Sorry, I just thought about that. Okay, that's not on this part. Alright, so the A part I think I already went over, so I'm going to fly through that. They asked you for G of 0, and you're going to need it later, girls, if they ask you for it. They told me that G of X was 1 to X of F of T dt. Keeping in mind this is G prime, which is also F. Alright, so I filled in 0 for X. We already talked about this. I don't really want to go from 1 backwards to 0, so I'll switch my limits of integration from 0 to 1. And what will I have to do? Make it negative? Okay, now it keeps a running total. This area was 2 by 1, or 2, but it's underneath. So I had to say it was negative 2. So what is G of 0 is 2. Okay? Like I said, they're going to find out if you know your calculus. Alright, G of 1 is kind of funny, because you go from 1 to 1 of F of T dt. What is that? What is happening? From 1 to 1 of F of T dt. What did that be? 0, girls? Now you know G of 1 is 0. And then G of 5 I'm not going to do, but you keep a running total from 1 to 5 only. Some of you went from 0 to 5. If you got 5 plus, negative 5 plus pi over 2, I'll do it. G of 5 is telling me to integrate it from 1 to x of F of T dt. Which this also plays a little bit into your homework. You've got to be really careful. Do you see all of this blue? We're about to enter chapter 7. When I start asking for area, which you need integrals for area of irregular shaped objects, but you have to handle your integral correctly. As for area, it's far different than asking for the integral from 1 to 5 as opposed to the area enclosed between the x-axis from 1 to 5. We've done that before though, okay? So in this case, an integral keeps a running total. And so I found the area of this, you could have called it a trapezoid. I actually found the area of this, which was negative 2. And the area of this triangle, which was negative 1. And then the area of the semicircle, which had a radius of 1, so it was pi over 2, pi r squared. So I have negative 3 plus pi over 2, which is a number. G of 5 is negative 3 plus pi over 2. You may not know what pi over 2 is without a calculator. It's probably a non-calculator problem. But negative 3 plus pi over 2, you know pi is about 3, right? Over 2 is about 1.5. So you know that's still a negative number. Running total. It's a pretty small one, I guess. Okay, then I'm gonna go up here. All right, to answer this in purple, I'm gonna kind of spread B around. G prime of 2. All right, well now I've already said this is G prime. I've already made all those decisions, girls. I did it before I started this problem. This was me making out my key. And I already wrote all of this stuff to myself and wrote the little G prime underneath that for me, okay? So I've already made this decision. F is G prime of 2 is negative 2. If you can put all this together, it's a super easy problem, which ironically was my intent. G double prime of 2, that would be the derivative of this. What is the derivative at 2 is undefined. And then G prime of G triple prime, is that what that is?
Yeah.
Of 4 with 0, because this is G prime. G double prime would be the derivative, which is 0. And anytime you have a constant, your derivative just keeps being 0 after that. Okay. By the way, that's quadratic, that semicircle. The derivative of that, if you think about it, would be linear. The derivative of that should be a constant, which then leads you on to 0. But let's keep moving. Are y'all okay so far? So now I have everything decided. Where does it have a point of inflection? I would say my possible point of inflection is at 4, okay? I also am considering 2, because it's where my derivative is 0 or undefined, but it can't be 2 because there's no sign change. So I've already spelled it out, but how am I going to answer it for the grader? I'm going to let them know how I knew in this way, okay? I'm going to say the point of inflection is F, let's see, how did they say it? What values of X, so I don't have to give the Y, occurs at X equals 4, and I wrote because G prime equals F of X, I got to pull that in together for the reader, G prime equals F of X. So I'm saying I know that that's happening, and G prime increases before 4 and decreases after 4. And at some point I want to say G prime of 4 is 0. You got to get all of that in there for point of inflection. Okay? Sorry, not G prime of 4. Second derivative, G double prime of 4 was 0. I got that all from the picture. All right, everybody listen, even if you're looking at what's for lunch, so listen carefully. I honestly would have to wait and see if I was reading this question for the exam this summer, and decide where they decided to give the points. You might get away with saying the second derivative changes signs at X equals 4, but they more want to know how you knew it changed signs. If I was going to say all of that, I would say the second G double prime changes signs at X equals 4 because you gave me the first, you don't have to say you gave me the first derivative, because the first derivative changed from increasing to decreasing. That's how you do it. Do y'all see what I'm saying? So go back to what they gave you, whatever it was. All right, and then the absolute max and min. Again, be very literal. Be very, very literal. On D, here's what I would do. You can get what's just called an evaluation, I forget what they call it. You could just show that you evaluated important points, okay? A table, tabular method, sometimes people call it like an XY chart. But what are my important points here for maxes and mins if I want it on G? Now I already have G prime. So I probably am going to show them that I evaluated it at 3, but the minimum might be at 3. I think the minimum probably is at 3, don't you? Because my function decreases and then increases. But do you know which endpoint is the max or min? Okay? Because it goes down and comes back up. And so I'm going to show the reader that I evaluated G of 0, G of 3, and G of 5. And they'll know that you know what you're doing. but it says the maximum and minimum, absolute maximum, minimum. Underline the word values. If I didn't do it on your paper, they want the y at that point, okay? On the interval from 0 to 5. G of 0 we already had was 2. G of 3, I have to stop and find. And G of 5 was negative 3 plus pi over 2. So let's find G of 3. We know G of x is equal to the interval from 1 to x of f of t dt. So I'm showing them I've got to stop and find G of 3 because they haven't made me do that yet. G of 3. So actually find the values and see which one's higher and lower. It's a candidates test, that's the word I'm looking for. These are my candidates for max and min, okay? Thank goodness I thought of the word candidates test. All right, G of 3. Let's go up here and find G of 3. Oh, I'm sorry, I'm going from 1 to 3, not 0 to 3. The integral's taking me that they gave me right up here, girls, from 1 to 3. So if I go from 1 to 3, I'm right in here. And this part I believe was negative 2, and this part was negative 1, so that part was negative 3. You kind of had already found it. So this is negative 3. And so the absolute minimum value, I would write the absolute minimum value, which they could share, but they don't, is negative 3. Girls, almost everybody in here is going to make you feel funny and weird not to say the point. So that's fine. I can just say that with my work. I can just say that. Or if it makes you feel better, report the value. The absolute minimum value is negative 3 at x equals 3. But spell it out that you know they want the y. If they don't want the y, they'll say at what x value does this happen? And then I would say the absolute maximum value is 2 at x equals 0. Okay? And the worksheet that I give you is going to have a lot of this stuff on it. Please don't just dive in and do the whole worksheet. It's all good review for what we've done so far. But you please check online. You'll have homework out of the book and a quiz on I'm only going to be looking at this worksheet when I make out the quiz. Okay? Kind of like when you study on LiveBinder and I can only pull questions. Those are like all the AP questions I have to pull from. So check, and I'm not through, check the, obviously take assignments before you start really super studying for the quiz, because I'll tell you what numbers to study that I would actually have on the quiz. There's a lot of, on this that you do need to practice, that hopefully you will at least practice a few of them where you're taking the fundamental theorem of calculus, the second fundamental, where you're taking the derivative of an integral. And those are on there, but I'm going to more be testing you on the graphing problems. Because apparently your teacher didn't do enough of that before. So get those on the way out the door. And let me move on to what we're doing now in chapter 7. Okay, so now we're going to start applying what we know. And so far, all you've seen me do is the area enclosed like this. There's a big difference in if I ask you the integral of sine from 0 to 2 pi, or if I ask you the area enclosed between the x-axis and sine of x, between 0 and 2 pi. You've got to look at the wording. An integral is a tool you can pick up, but you better use it wisely and don't ever, ever, ever find area or total distance traveled or anything like that without looking at a graph. Because I don't want credit for running a mile if you see me a mile away from the school, but I actually went 6 miles this way and you ran into me when I'd come back 5 miles that way. I want to go, I ran 11 miles, I didn't run 1 mile. If the integral's going to give you just displacement, it would give you 0 here, right? Are y'all okay with that? But the area enclosed, I believe, is 4 units. All right, so now, though, you're used to this. I think y'all are okay with that. You're going to be okay with what I'm going to show you also. You're going to have things like this that might intersect. And now I want the area between these two curves, okay? So if you're not told where they intersect, you might have to do some algebra to find where they intersect. And you're going to go top minus bottom top minus bottom. Do you see how I'm doing Riemann sums? Okay, now let's put it on an axis. And that may concern you, like, wait, don't do top minus bottom. Some of them are positive, some of them are negative. All right, let's say if this number out here is 4 and this is 1. Is that gonna give me the right length of that? That's 3 for that little rectangle. So that's okay. What if this is 5 and this is -3? How long should that rectangle be? It's working, isn't it? If you go top minus bottom, okay? So if I call the blue one f of x, and I call the white one g of x, if I say f of x minus g of x, and take the integral from a to b, I'm gonna get it right, because what happens with an integral, to remind you, it starts back here at this number, and an integral literally is a Riemann sum where you take the limit as x approaches infinity. Thank God, or Einstein and Leibniz at least, for the fundamental theorem of calculus, because I can get away with it by taking antiderivatives instead of doing those long Riemann sums, to remind you what's happening, okay? It'll start at a, and it'll start finding y values and subtracting them. Infinitely close together. Do y'all see what I mean? Until you get to what number? That's why your calculator runs for a while. Some of the ones with the LESR operating system take longer than others. Some of the newer ones go pretty fast. But y'all see it's gonna stop at B? So what's another word for f of x and g of x? It's just subtracting all those y values. Now how does that fit with what I've already shown you for weeks, if not months? Isn't that the line y equals 0? So it'll work if I go top minus bottom, or top minus bottom, okay? But what you've had on the top so far, or on the bottom, has been 0. You just didn't notice that you had two functions. Do y'all see that I have two functions up here? All right, now if I say 1 minus 0, it's gonna work. What about 0 minus -1? Do you see if I subtract, it's gonna keep the correct running total. It doesn't matter where it is, okay? You do have to watch for something like these two things happen. Suppose you had a red, y equals mx plus b, and a cubic polynomial. That's what I'm saying, please be sure you graph it. Don't just go from -1 to 5, suppose, if those are my limits of integration. I need to go from -1 to 3 with blue minus red, and then I need to make another integral from 3 to 5 with what minus what? Red minus blue. Okay? Now suppose these are both in the negatives. Okay. What if you have something like this? Is it still gonna work to say top minus bottom? All right, if this is -3 and this is -5, what's -3 minus -5? 2, isn't it? And don't you want the length of that to be 2 right there? So girls, I'm saying, whatever you think of, but wait, what if some of it's here, some of it's there? If you do top minus bottom, you're gonna be getting the right Riemann sums. You're actually doing antiderivatives, okay? Now, another thing before I do a really hands-on example that we don't do very much of, but it's very, very necessary. And you'll actually come to love this. There are times that something is twisted this way. Okay? That's probably a sideways parabola, right? But it's a y squared, not an x squared. Let me pause for a minute, ask questions if you don't get what I'm saying. Y'all see this would be a y, not a probably, this would be a y squared. Pointing that way, okay? If you have a y squared equals blah, 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 and you square root it, you've got a plus or minus blah, 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 blah. So you have an ugly square root green, and an ugly square root purple, and maybe another thing to catch it with. You'd have more, I've already done 2 regions, you know, where I had to, they flipped. one was on top and the other one was on top. So those are called regions. Do y'all see here, I would say green minus purple. I would have to say the positive square root minus the negative square root. An integral I'm not wild about taking, okay? But I would have to go green minus purple, green minus purple, green minus purple until I get to this. This is black minus what? Purple. So do you see I would have two integrals to do? Because I've got to make sure I'm getting my right wild values. Or I could do this. So fall in love with this. Watch. This can be red. I can actually go sideways. You're used to doing y's. Why couldn't I add up x's? I can go right minus left, right minus left, right minus left. How many regions? What am I doing? Thank you. But I'm also doing, very, very good, thank you. I'm also doing green minus black, 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 green minus
So you
black.
can just do it like that instead of
So
doing
you're
it.
gonna love
It's
doing
just
that.
crazy.
Also, you're not gonna have all those square roots in it. So let me do one. Alright,
You
so,
have to like.
alright, here's a good one. And I'll hurry, hopefully I can get this done in 2 minutes. Alright, so, an example in the book, you have g of y is equal to 3 minus y squared. And f of y is equal to y minus 1. Hang on just a minute, girls, and just listen, okay? Please listen and close your mouth. I didn't mean that rude, I just wanted to close your mouth, okay? What's another word for f of x or g of x? Y. So guess what's another word for f of y or g of y? X. It means now I'm climbing up the y-axis and finding my x's. Okay? So these are x equals 3 minus y squared and x equals y minus 1. You always want to graph them. 3 minus y squared. I'm going to make an XY chart. Watch what happens. You really need to see this. I'm going to fill in for a while. If y is 0, x is 3. Do y'all see how I just filled in for y and I got an x? Just like I fill in for x and I get a y. I went out that way. And then if I fill in 1, I get 2. If I fill in negative 1, I also get 2. 2, 1, and 2, negative 1. And this is x is equal to y plus 1. Most of y'all would probably temporarily make this y equals x plus 1 so you could graph it fast. Y-intercept is 1, and it's going up 1, down 1. It's almost what you notice. I don't want to do square root. I don't want to square root this. I'd rather go right minus left, right minus left, right minus left, right minus left. Which one's on the right? The what one? The parabola. So I'm going to go 3 minus y squared minus, which one's on the left? Y minus 1. You're going to have a dy. How are you going to know where to start and stop? That's going to be a pretty easy integral, by the way. How are you going to know where to start and stop? Aren't you going to have to find your points of intersection? All right, which you can do with algebra and factoring. The points of intersection are, you can go -2 to 1. You can all go. You can just watch the video.
Where does she have to be right now?
I know, it's kind of alarming, isn't it? -2 to 1.
She really sprinted out.
She may be president of a club or
But
something.
still, not
Who
today.
cares? You have 10 minutes.
Oh, I don't.
No, but like we do.
Oh, yes, okay. It's not my fault.
Yeah, you know, you still have to.
And I shouldn't go over it. It's horrible of me.
No, she's not wrong. It was just funny.
Okay, so back to this. You can find the intersections because you know algebra. If you're doing it in terms of x, use your x coordinates. If you're doing it in terms of y, these are my y coordinates. This intersection actually is -1, -2. And this intersection is 2, 1. Okay? And so it's going to start here, going right minus left, and it's going to stop when you get to 1. If you can set it up, do you see that's gonna be your biggest issue? I'm gonna give you 2 of them to get started, okay? Pick up a packet. I don't know what to do with Elena's packet. Does anybody else see Elena?
I don't know, like, where does she, she just like, I don't know.